Good morning, everyone. It's a wonderful Monday morning. I'm about to go to work, but I figured, could use a little coding session. Um, all right, today we are going to write the interpreter a little bit more because it doesn't really do anything yet. To recap really quick, last time what we've done is we've implemented the compiling two files, reading and writing, reading and writing the instructions that we do generate from the compiler, and then encoding and decoding them as well, of course. So, and then also we read them from the file, which is great, but we of course don't actually do anything yet. So let's jump straight into it. So first, by the way, first of all, the first episode blew up like a lot. Um, it's one of the highest viewed videos on my channel, so thank you for that. But do make sure to subscribe if you like the series. If you're on this episode already, you should be subscribed at this point because that would make sense and it would be much appreciated. Okay, so let's look at the interpreter. And also, I've made the font bigger because you guys requested that. Now, there's a lot of errors here because we haven't actually used any of these things yet properly, like stack, bytecode, stuff like that. Obviously, because we have not actually constructed this shit yet properly. We've only, did this for fun. But yeah, so one thing that I want to change is we want to remove the bytecode from the VM because realistically, all we want to do is start a VM and then feed it bytecode to execute. Yeah, that's probably a better idea. Can we maybe replace the qualified path? All right. Can we do even further? I think, but we don't really need to. Okay. So, so we need to keep track of so stack has a bunch of values on it, and values are just integers right now. And for example, the push instruction, we're going to keep the print, but we're going to modify it to have a little thing in front of it. It's going to make it easy to see in the logs. We remember compile exec test.mcl. Then we see now these will have the little arrow in front of it, which is nice. Okay. Also, one thing that I noticed while editing, which I do very little of, as you might have noticed, very low effort content, the pop instruction doesn't actually take an argument. It doesn't. So, I don't know what I was thinking there, but obviously it doesn't because it is it modifies the stack by popping something off of the stack and just kind of voiding it, if you will. So we don't actually want to do this, and we don't actually want to do this. If you can't follow along with this, it's fine. We did this last episode. It's not a biggie. All right. And also, self is mutable. We're going to get to that. And it's also wrong. That's nice. So like that. All right. So it's a mutable reference because we do want to modify the VM while executing. That's kind of the whole point. Okay, so pushing means that we do self, was it stack data? Well, actually stack data. That's kind of cringe. Let's just get rid of this intermediary thing. And that'll make it a little bit easier to read. Okay, so again, so the self stack push, and we'll just push the value that we have, which is instr.value. We'll do that first. And oh, of course, we need value integer because we decided that we might want to support other types later. Okay, we push that, and then of course we have self stack pop. Let's see, pop front probably. Do we actually want to do the push and pop? I think right now we do, but there's a lot of optimization to be had here. So I believe there's a pop front, right? It says there is. Also vec DQ. Okay, then we need to use a DQ. Makes sense that we need to use a DQ because it is. Is it a stack actually? No. A DQ is a double-ended queue. And I'm assuming that that's what we want because it will actually so we're going to push front or push back and pop back. So of course the stack is a first in first no, it's not. It's a last in first out data structure, right? The basic idea is that you can just push stuff onto the same side that you're popping from, because you always pop the top element, and so the top element is the back element in this case. The reasoning behind that is, of course, that it's a stack. If it was a queue, you would pop from the front and insert to the back, and we could do push front and push front and pop front, but I'm assuming it's implemented as a vector, in which case pushing and popping on the back is much more efficient because you don't have to like move too much stuff around. Okay, and then print does a print is supposed to pop from the stack as well, I believe. So pop is sort of a voiding pop. It just pops the value of the stack and then it's gone. You rarely actually use this, but like you might use this to if you have like iteration over something, and at the end you have something left over, you can pop it, but there's really no point in using it in anything else. And then self stack pop back gives you an option. All right, so if let some values, then we'll just say print the value, right? Let's just use print line and just print the value. Do we have? Yeah, let's just print it like that. Because yeah, let's implement standard display for it, I guess. Do we want to do that, or do we just? Okay, but right now let's just do our own match statement here because I don't feel like doing that. Right now it's just like this. So it's an integer print line. And okay, so that implements all our instructions. And this is really all an interpreter is, right? Interpreters just run the thing, right, by going through every single instruction and doing what it's supposed to be doing, right? Some coffee. Today we have instant coffee with instant decaf mixed because I ran out of instant coffee. Very yummy. Can recommend. And oat milk because I'm fancy like that. Okay. But of course, I did experiment a little bit between episodes. I did have a little bit of time since the last time I recorded, and I did build a little JIT compiler. And I think that we want to maybe add a JIT compiler to this just for the fun of it. But I'm probably going to do that outside of the series so that it gets more attention because it is probably quite interesting to build that. I haven't done that before properly, so excited for that. It's pretty simple in Rust, so why not? Okay, and then unreachable pattern because we don't have any more instructions. Okay, so let's run the code we have, and it doesn't compile because vm.execute interpret new VM that's in main. Because we obviously want to make this mutable. Oh, sorry, that's a Vim problem right there. All right, so push to push. Okay, it's a little bit ugly. Let's go and actually write these before. Let's have a look. Okay, so push 2, push 1, print. That's the one that we just pushed. Print 2. That's the 2 that we pushed before. So I don't think I have to visualize the stack here. Guess I could. So let's do that. So stack. Just print it in one line. Oh, because value doesn't implement debug. So the cool thing about Rust is that you have these traits and you can just derive them if they're like derivable. It's really nice. Okay, so now the stack has a 2 on it. Now the stack has a 2 and a 1 on it. And the top of the stack's on the right. Top and bottom. Yeah, so now you can tell that like the whoops. Okay, now you can tell the stack is growing 2, 1, 2, and now it's empty at the end, I'm assuming. So makes a lot of sense. Seems to work. Now let's implement some more instructions. So if we go back to, where is she? Okay, let's go back to this and let's go to my profile really quick and go to MCL. Sorry for the flashbang there. And here we have the instruction reference, which we're going to use. So actually, I don't think this instruction reference says everything. So we need to go look at the source code because I'm terrible at writing documentation. This also doesn't say what they are, but we can just implement them the same way. So I think so far we didn't do it correctly. So we will need to change them. So not an instruction is 0, which we don't actually have to build. But let's look at the instruction. I think it was inster. That's fine. Let me just, I must have shut it down in some weird way before. Okay, so the upgrade, that's actually what I want. Okay, so these are not implemented correctly. So we have not an inster at 0x0, but really we have pop at 1. And then if we go back, sorry, you can't actually see what I'm typing because I'm just here, but this makes sense. So we want to take all these, basically just copy them into our editor. Sorry, I let you look at this for so long, but it does make sense a little bit. So, so we did actually do all these in like the wrong case, but that's okay. We can vim magic this to be the right case. All right. So these are all the instructions that exist, and we start with pop at 1, add, and so on, right? Let's see if that still works. Still works. So of course, exactly what these encode to is not particularly important in general. For us, it's important because we're trying to be completely compatible with this original MCL implementation. So that's why we need to sort of exactly copy these. And there's also some more reasons for why they're ordered like this, like the pushes here, because these are ordered in terms of, do these need any arguments? Because the only things with arguments is, I think, push and jump. And that's all, right? And so all the other ones don't actually have arguments. So you can use is equal to or greater than push to figure out if something needs an argument. In our case, I'm not sure if that's going to be relevant because we're strongly typed, but they still need to be the same value. Like this is 2, 3, 4, 5, 6, and so on. They need to be the same value so that we can compile with the old one and run with the new one. All right. So now if we go to the compiler, it will say that, of course, we, yeah, let's actually show some like some nice development here. So what we're going to do is we're going to push two, we're going to push one, we're going to add them together and then print. So this is the first sort of actual use case, you will, that we have here. So, and actually, you know what I'm going to be doing? I think, oh no, I'll do next streams, next video, so that you can see my whole screen, not just the editor. All right, so if I do that now, then it will error. It will say unexpected token add because we've implemented a nice tokenizer. And so instead of crying about it, I'm gonna go. What the fuck is still running? Oh, am I still looking at it in a different view? I sure am, probably. Yep, I am. All right. I had it open in a different view. Okay, we want the compiler. First, we need to implement it here. Let's see here. So we need to say add token up add. Okay, that builds that. Then add doesn't take any arguments, so it's just going to be this. All right. And now we're going to run into the invalid instruction, which is a panic. And of course, that's not quite right. It should be a to-do panic. Let's run it again. So now it says not yet implemented invalid instruction. So instead it should be format and up. What's the op here? Insert up. And okay, I need to, of course, do that. Might be missing a string literal. Oh, does it? Oh, does to do already have that? That's nice. Wonderful. Okay, so now it says not yet implemented op add. That's actually up. Okay, op add is not implemented. So, what do we got? We need to do op add print line. So now we debug print what we're actually doing, and we do need to do that later. So first we need to pop two things. Okay, we need to pop self stack pop back let a dot is well, is it okay or could do that. We'll just keep it simple. So we're gonna let A, let B. And actually this was confusing because if we assume that it's A plus B and they're not like you can't exchange it, which you can, then it's actually we first pop B and then we pop A. And this is really relevant later because we're gonna implement something like division where the order of operations is important, and then it's important to have sort of a consistent. If we just copy this code for the division, now it will be fine if we divide A by B, otherwise we'll get the wrong way division, or for subtraction, if you will. So, so A, B. Okay, and we need to, of course, go implement value. This doesn't implement display. Oh, let's just, can we just do that? No, it can't. Okay. In that case, let's do that. Okay, so we're gonna add those together, and the way we do this is a sort of I think in Lua you would write a little thing above it that says like it does this to the stack. So what this does to the stack is actually it just removes one element from the stack, because effectively it takes two, but it adds one back, right? So in terms of stack math, it removes one, but it changes another one. Okay, and so, oh, of course they are. This is why it was complaining, I think, because option doesn't implement format display. Okay, so if let's b plus b some a, and if there's a better way to do this, please let me know. Been wondering. And this still doesn't work. Okay, well, at least now it's interpreted value. So now we can say self stack push back a plus b. Oh, of course, they are still values. So not in a typing mood today. Value integer a. All right, and this again needs to be wrapped in a. Of course, we don't need that because we're already in there. I don't know why Rust Analyzer is such a dumbass. Sometimes it's truly impressive. Okay. Let's review. We got A and B from the stack. We checked that they're both integers and they both exist. And then we add them together. Sorry, I keep jumping. It's like I keep typing shift and then moving and it fucks it up. Then we add them and push back the result. Pretty cool. But error cases, right? And this is where it gets a little bit ugly. We will have to sort of create a. Let's do that now. So this result returns an anyhow result already, but really we want to here. There it is. So we have another error type. This is stack empty. Just do that. Because the stack empty is sort of, I think that happens here a lot. So let's just return a result and interpreter error. I don't think we're going to get any other errors in here because we don't really do anything else. And then let's figure it out. So we might want a function, it doesn't have to be public, probably shouldn't be public, that says yeah, so get stack top, and that's going to return a result of a value with an interpreter error. Just so we get this a little bit more cleaned up, right? So if let's actually in this case we can actually do, this needs to take a mutable cell. So stack pop back, okay, or interpreter error, stack empty. I think that should do it. Okay. I mean, we could just use this directly, but I feel like this whole thing, we could just use this directly, but I think it's nice to have a sort of function that does this, because later we might want to not just throw an error. Maybe we want to do some more checks or whatever, or we want to add like a type argument. So let's just leave it like this. And okay, so that's in case the stack top is like that. So now let's figure out how we can do a type check on it. So this will actually become get stack. Well, it should be pop, shouldn't it? So it's going to be pop stack top. Nice. It's a little bit easier to read. And then these basically become simple if-let statements. I know they will always match right now, but we can add more stuff like strings, floats, stuff like that. And this might very well end up being important that we actually do type check them. However, the add instruction is probably going to work for all types, like even strings, I'm assuming. So I'm not entirely sure if we want to have a type check with an error here. Maybe, yeah. Okay, let's just add a little error here for now. That's going to be invalid type or something. And then it's going to be invalid type. And it's going to be a value. Okay. All right. What does it want? As a derived input for the trait debug, but this is okay. Sure. Dead code analysis. So else return interpreter error, invalid type. Oh, we should also probably tell what we're expecting. Expected that got so let's just do this. Or can we let's make a expected or I think this is good. All right, so we want to return interpreter invalid type with we expected an integer and we got a try wrapping it in oh, it's a bit verbose, but it is what it is. Okay. Oh, like this. Bit of a silly goose here. Okay. And then again, else. Now, you know, this can be prettier, but right now we're not actually gonna run into this case, so I don't really care. Okay, so push 2, push 1, add. So adding 2 and 1, I think we don't actually have to print what they are because it's kind of confusing. It looks like they're immediate values. So 2 and 1 turns into 3, and then we print that and we get 3. So we don't actually need to print these. That was a silly idea. Now, let's try out some of these error cases just for fun, and we'll write some tests later. It's not particularly nice to look at, so, you know. The test.mcl program, let's just push one value and then do add, and we'll say error stack empty, right? So because we do expect more stack arguments and we didn't get them. Let's do this. It's going to be super funny. Let's do that. Okay, so yeah, works perfectly fine. Okay. So let's commit that. Implement interpreter. Okay, beautiful. So that is us building that part. Pretty fun, pretty cool. And I encourage anyone to build this, like also build one. it's really fun to build little interpreters for toy languages. But we're gonna go pretty hard on this. Like we're gonna do some more crazy shit. But you know, we will see. I think that concludes it. We can leave it here. I mean, we could just add more instructions, stuff like that, which I might do off camera. I'm not sure yet. Like we have inc, dec, like increment, decrement, subtract, multiply, divide, modulo. Then we have halt, which is, we didn't actually implement that. We just halt by default, but it's like at the end of the program, you automatically halt. But anywhere in the program, you can just have a halt statement and the entire machine just sort of terminates. Then you have dupe and dupe2. Dupe is duplicate. So what it basically does is it duplicates the stack top. So if you have like a 2 on the stack top, you do dupe, then you have a 2 and another 2 on the stack top. Dupe2 is if you call dupe twice. So this is an optimization we're going to make. You're not going to actually be allowed to write dupe2, but if you write dupe twice, like dupe, then you will get a dupe2 instruction just to save on some. And this has serious performance implications. We'll see that later. Of just optimizing that. There's a swap, which swaps the top 2 things on the stack. We have clear, which clears the stack. We have over, which basically say you have like 1, 2, 3 on the stack. Then if you do over, then you have 1, 2, 3, 2, because you've basically grabbed this 2 and moved it over here, like copied it over here. This is incredibly useful if you get into more complicated programs. Then we know push. Then we have these jumps. So jump if equal, jump if not equal, greater, lesser, greater, equal, less than, jump without, like let's just go to, and then jump if 0 or jump if not 0. These are special because they are optimizations, but you will be able to write them as well. So if you do a push 0, jump equal, it's going to turn into a JZ. Same with J and Z and so on. So these are some little substitution optimizations that we can do later. I'm not going to do that right now because right now I'm all out of time. Thank you for watching. Make sure to subscribe, like the video, and comment down below if I fucked anything up or if you have any suggestions. And I'll see you next time.